Now we begin dealing with the function that's specifically describe a simple harmonic motion. The position is given by some amplitude. Usually we use cosine by convention, some angular frequency times time plus some kind of phase shift. And because it's a motion, if we derive it, we'll get my velocity at any given time, which, if you know from your calculus class, cosine derives into negative sine, and using the chain rule, the omega here comes out, so we have omega like that, then everything in the back stays within the argument of the sine. Derive it again, we get that, and sine, as you may know, derives into cosine, and this all stay, and then we get an extra factor of omega. So this also tells us there's some relationship between the maximum speed and the amplitude, as well as the maximum acceleration and the amplitude, because you can see that is the amplitude of the velocity, which is the maximum speed, which is just amplitude times omega, and acceleration is amplitude times omega squared because of the way the derivative works. And from here we can just pick out amplitude and frequency and period, and hopefully we can answer this in fairly quick, kind of rapid fire kind of way. Let's sub in the actual numbers so we can see it all together. Ooh, just made it. Right, so then let's see. So part A is going to be, what is the amplitude? Well, the amplitude is easy. If we're given the position function, we just look at the amplitude of the position function. So amplitude, that's just a simple read off, is 8.00 meters. Done. B, what is the frequency? Now, frequency is F. It's related to omega, but it's not quite omega. Frequency is measured in hertz. So here we know omega is equal to 2.00 per second. What's not written here is radians per second. But we want cycles per second, which is hertz. So the conversion is basically multiplied by how many radians per cycle. We want cycles up top, and we want radians on the bottom, so we have to divide by 2 pi. So basically frequency is omega divided by 2 pi. So then we have 2 divided by 2 pi, giving me 1 over pi hertz. So the frequency is 1 over pi hertz. The period, this part C now, the period is 2 pi over omega, so that's going to be 2 pi over 2 per second, giving me pi seconds in terms of period. And once again, if we see pi, we tend to leave pi in there just to avoid long giant decimal places. And B, this is the fun bit where we talk about the maximum acceleration. Well, the A max, as you can see over here, is just A omega square, which in our case is 8.00 meters times 2 second minus 1 square. Even has the right units, so that's 32.0 meters per second square. There's your A max. E, my V max, is A omega, so that's 8.00 meters times 2.00 seconds square, giving me 16 meters per second. And then finally, we need to we're asked to sub numbers in. So this is more or less a calculator exercise. 8 meters, I know has 3 sig figs. Just remember that you have to use the radian mode on your calculator in order to get the right answer, because everything in here we expect to be in radians. So the seconds cancel out, leaving us with, again, radians. So an 8 meter cosine, so then pi plus pi over 3, so that's 4 pi over 3. Some people have this command in memory, but you're not necessarily expected to in my class. In math class, you might have been. So you just plug in your calculator once you have set it up in radian mode. It's going to give you -4 for your position. -4 meters. If you want to keep sig figs, we have 3 sig figs, so -4.00 meters. Now I want to change it to talking about velocity. Notice that everything inside here stays the same. So this piece basically stays the same, so we don't have to do that math again and again. We already got the amplitude for my velocity function, so again, this is pretty straight up plug and chug. So v at pi over 2 seconds, it's going to be, we talked about how this is 16.0 meters per second. This is negative sign, don't forget the negative. And this is once again 4 pi over 3, because everything inside the sine function was the same as what it was inside the cosine function. And we get some number, here's 13.856 meters per second in the positive, which we will basically round it to 13.9 meters per second. Same thing for my acceleration. So this we talked about being 32.0 meters per second square, negative cosine of 4 pi over 3, giving us positive 16 meters per second square. So this has many parts, so I'm not going to necessarily write out all the sentences because you don't have to see me type, but here's how you get all the answer relating to the simple harmonic motion. It's the fact that you don't just have the one cosine function, but you derive it a couple times. You get a sine function and cosine function as well, and their amplitudes are related, as well as this argument stays pretty much the same. So it's relating all the different things, and we can even talk about energy in the next example.